All right, hi everyone. Thank you for joining us. We have Laura Arditti from Larus, and she'll be talking about determining the value of users for a payment app, the YAP case study. So over to you, Laura.
Thank you very much, and thanks for having me today. So graph data science allows to go beyond entity-centric approaches by extracting value from connections. And we have seen that this is true in a great variety of contexts in this conference. Today, I will focus on a special setting, which is that of online payment platform, and I will present the case of YAP, which is the online payment app by Nexi. I will try to answer to a very specific question, which is how can we measure the value of users on a network-based platform? So let's start by describing the setting of this problem and, most importantly, the motivation of our work. So as I was saying, YAP is the mobile payment app by Nexi that, after an in-app enrollment, is active as a MasterCard prepaid that is accepted by millions of merchants both worldwide and online. However, YAP is much more than just a prepaid card. It is a service, so it allows its users to interact in multiple ways. For example, by splitting bills, sending and requesting money, and inviting new friends to join. So in this setting, one of the main goals of the YAP team is to understand what is the value of a YAP user and be able to measure it operatively, as this is clearly crucial to drive business decisions such as deciding how to shape new marketing campaigns. So classical user-centric approaches that measure the value of users solely based on their individual spending activities show poor capabilities to capture the value of users in contexts that are characterized by a network of interactions, such as YAP. So the need was revealed to derive new and more effective measures to drive the operations at YAP. At Larus, the company where I work as a data scientist, we are specialized in graph technologies and graph data science, so we offered our expertise to YAP, and we proposed a change of perspective. So as YAP is a network of users constantly expanding by means of member-get-member mechanism, a good measure of users' value must not only describe users' spending activity, but it must also capture the way each user contributes to the creation of a good quality network. So this was the main motivation to build an appropriate graph data model for YAP data. Indeed, by modeling data as a graph, the network structure that we identified in this problem can be made explicit in our data representation. So as probably many of you know, modeling data as a graph means identifying those entities and relationships that play a significant role in the problem. And in the case of YAP, significant entities are users and merchants, represented by orange and blue circles respectively, while significant relationships are invitations among users, represented by bold orange arrows, and P2B transaction from users to merchants, represented by thin pink arrows. Notice that we did not consider peer-to-peer money transfer at this point, as they do not directly generate monetary value for the company, but we'll be considering them later. So we implemented this data model within the Neo4j graph database so that we could directly query the graph for patterns and visualize the results in an intuitive fashion. And as an example, here in this picture, you can see a little portion of this very large YAP network. So based on this data model, we wanted to derive an effective way of measuring the value of YAP users. But to do this, we needed to understand what the value of a user is in first place. So we identified two components that contribute to the quality of users. The first one is what we call the intrinsic value of users, and this is the value of a user seen as an isolated entity. So basically, this is a score that describes users' spending activities. On the other hand, we have what we call the network value of a user, and this is defined by other users that are directly or indirectly connected to her by means of invitations. Indeed, as you can see in this right picture, invitations of users spread in the network, and we are able to identify a whole community of users that entered the network as the direct or indirect effect of the action of a single root user. So basically, the network value of this root user is defined by the quality of his community. I'll go into details on this in a few moments, but for now, just notice that when defining network value, it's not about the quantity of users that are invited but it's about their quality. So each of the two components that we identified capture different partial pictures of users' value. And in particular, even if it captures an important aspect of users, intrinsic value alone is not a satisfactory way of describing the value they bring to the YAP ecosystem. Indeed, it is not able to distinguish between two users that have a very similar spending activity, but a very different effect on the network. And this is an example of this situation is displayed in this slide, where on the left we see a user with high intrinsic value, but with a little network value. In this case, this user have a good spending habits, but invites only three friends of poor quality that do not spread the invitations any further. Instead, on the right, we see another user that have a similar intrinsic value, but a much higher network value. So this user again invites three friends to join, and all of them are of great quality. And basically, this user starts an invitations process that spreads very far. So these two users are clearly very different, but they are indistinguishable under the lens of intrinsic centrality alone. So basically, we understand that from this example that what we aim at capturing, that is the impact users have on the YAP network, is not contained on the data about individual users' activity, but this is codified in the way these data are connected to each other by means of a network of invitations. So to address this problem successfully, we need to consider such structure. And that's why we developed our analysis within the framework of graph data science that is able to take the most out of connections. So concerning the description of our method, after the implementation of the already discussed graph data model, the next step was the computation of the intrinsic value of users. And in practice, this was obtained as a single score, combining all relevant properties of users, individual properties of users. And in particular, it was obtained as the product of four factors. The first one accounting for all the spendings of users, so their transactions amount. Then we have two factors accounting for frequency and recency of transactions. And finally, an expansion factor that accounts for the number of invitations sent by each user. All these factors are designed to reward or penalize good and bad values for the corresponding quantities, and they can be customized according to business knowledge. Adopting a graph schema allows also to exploit graph algorithms to elaborate data, leveraging the structure of connections. And in this case, we opted for a custom graph algorithm that is adapted to the special problem at hand. So one of the special features of our setting is that the network describing invitations in YAP is a forest, meaning that each user can send multiple invitations, but he can only accept one. So our algorithm combines the structure, the intrinsic value of each user with the structure of the network of invitations in such a way that the user is rewarded for inviting other good users, so other users that expand the network and have good spending activity. I'd like to spend just a few words on the main ideas at the base of this algorithm. So in designing this algorithm, we were inspired by the literature on averaging processes that are used to model the formation of opinions and conventions in social networks. So in that context, it is assumed that the opinion of each individual is locally affected by that of its peers, as each individual forms their own opinion by combining a personal belief with that of other people in their neighborhood. So we adapted this idea to the setting of online payment platforms, and so that in this case, the value of each user is obtained by combining intrinsic value with the value of other users that are connected to her by means of invitations. So the algorithm reflects the expansion mechanism of YAP. As we have seen, when a user sends some invitations, each of the new users may propagate these invitations by doing the same. So the first invitations start a sort of cascading process that leads to the expansion of the network. And so our graph-based measure of user value combines the intrinsic value of each user with the quality of the network, of the community the user contributes to create by starting the cascading process. We implemented the computation of this metric within a message passing framework thanks to the Neo4j Pregel API by propagating the value of leaf users upward in the graph. So by comparing the outcome of this algorithm with the starting point, which is the intrinsic value of user, we are able to directly measure the so-called network effect, meaning that we are able to quantify the role of connections in determining users' value. And in this picture, we see the joint distribution of intrinsic and network value for users. And what's interesting is that we see a lot of users with poor intrinsic value, but with high network value. So these are all users that are valuable to YAP, but that we completely lose if we remain in a user-centric perspective. Finally, the last step of our process is the tuning of model parameters. Indeed, the model we propose is highly flexible, and there's a lot of control on a lot of aspects, like what are the most important factors in determining intrinsic value of users, and what's the relative importance between intrinsic and network value. So what we propose is a framework that can be shaped by marketing and business insights. So this flexibility makes, on one hand, it makes crucial, the tuning of parameters crucial, and requires a joint work with business experts. But on the other hand, this is what makes our approach widely applicable. So let's now pass to the outcomes of our work. This work produced both descriptive and prescriptive results, thus impacting both the operations and the understanding at YAP. And I will just quickly overview some of these. So starting with the descriptive results, the value score we derived can be used to answer business questions. Starting with the first one, which users have the largest impact on the YAP network? We can easily answer this by extracting users that bring the most value to YAP. So we can then further analyze their connections, trying to identify some common patterns. For example, do users with high value tend to be the center of star-shaped communities where they play the role of a hub? Or do they tend to be the root of long chains of invitations? We can also analyze the behavior of top users by looking at what's their typical usage of YAP. For example, here we analyzed their favorite categories of product by looking at the most frequent endpoints of their transactions. Finally, we can widen our perspective and look at what are the most valuable categories of users. And we can do this by analyzing the distribution of some properties of interest over the population of top users. Here, for example, we see the distribution of age over high-value users, and we can clearly see that young users bring more value than older ones, but there's also another community that brings a lot of value to YAP, and they are users around 48 years old. We can look at the evolution of value over time by periodically computing our graph-based measure as new data is acquired, or by analyzing different slices of past data obtained with a moving temporal horizon. And we perform such a temporal analysis by analyzing around 3 years of data starting from 2018, including 3 months of data at a time. The result is displayed in this slide, and we see that the distribution of value that is displayed in a log scale spreads as times move forwards. And this represents the progressive acquisition of new users and the growth of the overall value they bring to the platform. This kind of analysis may be useful to identify significant events that led to a change in the value of users. And in turn, this can help to understand how to control the evolution of the user base. Finally, we can use our measure to measure the value generated by marketing campaigns. So instead of just counting the number of new acquired users, we can measure the value as they enroll. So this allows to identify what marketing campaigns are able to attract more valuable users, and in turn, this helps understand why such campaigns are more effective than others. As an example, here we see in the top picture the number of users acquired for each campaign under analysis compared to the average value of users for the same campaigns. And this comparison immediately highlights the most successful campaigns. On the same line, we can also measure the return of investment of campaigns by comparing the value of newly enrolled users to the amount invested for their acquisition. On the prescriptive side, we can use our value score to derive to drive the marketing decisions, such as on what users should we invest more. So as we see in this picture, which shows the distribution of value over the whole population of users in log scale, the value is concentrated on a very small portion of users. So this means that flat investments target users that mainly produce small to no returns. So this reveals the need to design some targeting strategies. And the very first, the most simple and intuitive targeting strategy is to target users with high values to incentivize them to spend more or to invite other good users. However, other kind of strategies may as well be needed when the value extracted from high-value users saturates. And this happens since users that already have a large network of peers and good spending activity may not be able to improve their performances even when given an incentive. So in these cases, one possible approach is to concentrate investments on users with high potential. And for example, we could target users with low value based on their peer-to-peer activity. So in this graph here, we see the joint distribution of users' value and their peer-to-peer transactions amount. And we see that there are a lot of users with low value that transfer a lot of money to their friends. So despite being inactive on the P2B sides, these users have high spending capabilities since they transfer a lot of money, and this makes them potentially highly valuable. So these are just some of the applications we explored, but there are a lot more, and this is still an ongoing work. So to conclude, I would like to focus on what are the next steps. So the whole process I presented should be automated by creating pipelines for periodic data processing and for updating both the model and the results as new data is acquired. We are working on a graph data science platform called Galileo XAI that allows to automate graph data science project, and we'll also use it to complement our analysis with advanced visualization that make the graph and the results easily navigable and understandable. So in this way, all the analysis I've presented can be engineered into a service to support the operation of end users, such as business experts at YAP. So this concludes my presentation. So thanks a lot for your attention. And I would really like to hear from people in the audience. So if you, for example, work in the field of online payment platforms, I'd like to know if you think this approach may be useful to you and if you have any idea or suggestion on how to improve it. If instead you work on completely different problems, I'd like to know if you think that this approach may be translated to your field of application. So any suggestion, any question and comment is welcome. Then also feel free to reach out also on LinkedIn and via email. Thank you.
Thank you, Laura. We do have one question, and folks, please feel free to use the Q&A feature. One question is, did your graph contain cycles, and how did you deal with that in regards to message passing?
Okay, so that's a nice question. Thank you. I didn't spend much time on this, but you can see here that actually this is sort of update rule that we can apply to compute our measure. And there's a damping factor, which is like a way to discount the influence that your neighbors have on your own value. And this damping factor is a quantity between 0 and 1, strictly less than 1. And this is guaranteed to for having convergence of this message passing process. All is in this damping factor, basically.
So the damping factor helps ensure that message passing isn't, it's like if you do have cycles, it's not going to kind of,
if you have cycles,
increase the value too much. Yeah.
Exactly. Even if there are cycles, your value it does not increase unbounded. The presence of this damping factor ensures that it stays bounded and converges to, and the message patches framework actually converges.
So I don't see any other questions, but I was kind of struck a little bit by the idea that you sort of talked about the difference between the intrinsic value and then the kind of network effect. So essentially the value of a user is both affected by their intrinsic value, but also the value of everybody that they're connected with through like a pretty large graph. And I was just kind of thinking about how that, to me, seemed a little bit almost similar to the question of page ranking, or sort of the original approach we heard about with Google and other search engines, where the relevance and the ability for a particular page to show up higher in rankings, not just what the content is, but how many other pages it's connected to, and maybe what their value is. Actually, I don't know if that's true or not. But
yeah, thanks for pointing this connection out. Actually, this the approach we propose is a sort of dual to the PageRank algorithm. From the mathematical point of view, this is a dual algorithm to the PageRank. And what is different is just the direction of influence. So in PageRank, the importance of a web page is determined by that of pages that link to it. Sorry. Instead, in this context, in that of users in YAP, the importance of a user is determined by other users' e-invites. So the direction of influence is the opposite with respect to PageRank. And that's why these algorithms are sort of dual one of the other.
Yeah, that's really interesting. I did have a question. People, please feel free to ask more. So you had that one slide where you said we wanted to kind of understand whether the patterns around high value users were they the center of like a network, or were they like one with just of like a long line of invites? Yeah, that's the slide. Did you find out what the patterns were in this case, or did you have any results? Like, were people more likely to be like the center of a network, or were they more like the one on the right?
So among these two patterns, this one, so the star-shaped pattern is more frequent for high-value users, but actually these are just the two extremes, and there's a lot of possible patterns in the middle. Actually, also referring to the previous question, our graph, the graph of invitations, does not contain cycles. It is a tree. So we have all possible different trees that span from a line to a star. However, yeah, we are trying to perform also motif analysis to understand if like the structure can be an indicator of relevance for users in the network, and the star-shaped pattern is actually recurring very, very often for high-value users. So even if our graph, just to refer to the previous question, our graph does not contain cycles, and this make the message passing framework very fast for computing our measure. Still, this approach can be applied in presence of cycles because we designed our algorithm to be applied more in general, and that damping factors allows for this.
Okay, thank you. That was helpful. It does seem more, intuitively, it seems like the star-shaped one would be frequent, but it's interesting to hear that it's all sorts of, you're looking at all sorts of tree patterns that are coming out,
Yeah.
even if that one is pretty frequent. Did you have anything else to add? I don't see any more questions, but I think you already said if people wanted to reach out to you with questions, they can do that.
Yeah, I just want to say this again. I encourage everyone that is interested just to reach out on LinkedIn or via email. I would be happy to start some conversation and also to understand if this approach can be useful in other different contexts.
Well, thank you very much. This was fascinating, and all the work you've done was great. So thank you for sharing.
Thank you very much.
Bye.
Bye.